Assalamualaikum and good day. Today we're going to start our lecture with chapter 1, which is stress, strain and modulus of elasticity relationship. So for the first chapter, I'm going to do the recorded video since this is the easiest chapter from all of the chapters in our syllabus. But starting from the chapter 2 up until to the final chapter, it is going to be in Google Meet. Much easier for you to understand lah, because basically I will teach you directly like that. Then we can do the example together. Without further ado, let's proceed. So what is stress? Is when a force is transmitted through a body, the body tends to change its shape. Although these deformations are seldom visible to the naked eye, the many fibers of particles that make up the body transmit the force throughout the length and the section of the body, and the fibers doing this work are said to be in the state of stress. Thus, a stress may be described as a mobilized internal reaction that resists any tendency towards deformation. So, for example, if you have a spring, okay, so spring ni boleh ditarik. We can pull it, so dia akan memanjang. Okay, so bila you tarik, you akan rasa ada something yang resist a force. Force yang you tarik spring tu akan ada something yang resist you daripada pull it. So dia tak memanjang, dia tak elongate. Maksudnya ada particles dekat dalam tu yang menghalang you daripada tarik partikel yang dalam spring tu. So keadaan dalam particle yang very very small tu, dia ada reaction sebab we know that this is as what you know, equilibrium. So equilibrium ni, whatever yang going up will going down, whatever that going to the right will go to the left. That is the state of equilibrium. So that's why spring tu tadi ada internal reaction daripada the particles fiber inside that spring yang try to resist the force yang you pull the spring tu. Okay, so dia nak resist daripada deformation. What is direct axial stress? Tensile and compressive stress, which result from forces acting perpendicular to the plane of cross-section in question, are known as normal stress and usually symbolized with sigma. This is a Roman symbol. So kita pakai sigma for normal stress. Okay, so for normal stress, for example, I have a cylinder here, right? So if let's say forces going down, so this one is compressive force, and forces pulling up, this is tensile force. We have two types of force which will result in, if let's say compressive force, it will result the object to be shorten. Okay, dia akan memendek lah. Okay, bila memendek, dia dalam state of stress, which is compressive stress. And this one is tensile stress. Okay, so dia perpendicular. Okay, perpendicular to the plane, which means it is 90 degrees. So plane yang mana? Okay, you cut this. Okay, it can be any cross section, any part of cross section of the object yang in tension ataupun in compression tu, yang in stress tu, ya. So any part of it, tak kisah mana-mana. So kalau dia perpendicular, meaning that dia akan bulat lah cross section dia, ya. Sebab the force itself is perpendicular to the plane. So mana plane dia, any cross section. So cross section perpendicular mesti bulat. So that because of our object is bulat, so that is normal stress. Then we look at the shear stress. Shear stress is produced by forces acting parallel or tangential to the plane of the cross section and is symbolized with tau. This one is tau. How about shear stress? Shear stress, if you have a cylinder like this, then the stress is going to be P. Okay, I cannot sebut parallel. Okay, so I call it P, or tangential to the plane. So this is the force there, which is the shear force. So shear force, where is the cross section yang being affected? It is P to the force. So P to the force ini kita panggil P lah, which is parallel to the force. Cross section dia masih sama, bulat, okay, macam tu, tapi dia adalah shear force because of kalau force ni makin lama makin besar, contohnya force tu besar, cylinder you boleh break into two. Okay, so shear force ni will cause the object to maybe crack. Okay, then later on, if let's say the force is too much, then it will break into two, where it will split, right? So that is shear force. So this object is in shear stress. Then we look at, okay, when a force is applied to an elastic body. So this one we are talking about normal force, which is we have compressive force and tensile force. When a force is applied to an elastic body, the body deforms. The way in which the body deforms depends upon the type of force applied to it. A compression force makes the body shorter, a tensile force makes the body longer. So this is what I explained before. This is the example of the object that being applied the compression force, and this is the object that tensile force being applied to it. Okay, now we look at the formula. Stress is equal to force per unit area, which is force per area, and then sigma, which is stress, the normal force here, equal to the F divided by A. So that is the simplified version. Okay. Stress is a load effect. Stress by definition is relationship between force and a particular area. In order to define the stress quantitatively, therefore the force, which is a vector, must be defined, and in addition the configuration of the area in question must be defined. The following information is required. You ever belajar about physics before, you will know that there is two type of force. There is two type of unit. Okay, you ada satu vector and another one is scalar. Okay, so kalau skala ni dia ada quantity tapi tak ada direction. Tapi kalau vector dia ada quantity dan dia ada direction. So force adalah vector sebab dia ada quantity and dia ada direction. The following information is required. You need the magnitude of the force since this is the vector, and then the direction sebab dia vector, and the plane in which the area lies. Okay, for example, we have X, Y and Z. X is 3D. Jadi, kena ada all this information so that baru kita boleh kira. Unit of stresses, it doesn't matter, you can use Newton per mm square, meganewtons per square meter, any units that you can choose. Okay, as long as ada Newton, which is the force kat sini, dan ini adalah unit area. Okay, jadi mesti ada these two. Okay, but basically for the calculation in my class lah, I prefer to use Newton over millimeter square, because this one is usually being used bila kita kira stress. Now we look at the example 1. A bar of steel 2000 mm square of cross-section area is being pulled with an axial load of 180 kN. Find the stress in the steel. So we have the formula of sigma, which is stress, is equal to force divided by area. So you just simply take out what you have in the question, what the question give you the information. 180 is the force, right? And 2000 mm square is the cross section, which is the area. Therefore 180 kilonewton ni, since I cakap tadi I prefer newton over mm square, so that's why kita darab dengan 1000, because 1 kilonewton is equal to 1000 newton. Tukarkan kepada newton, kita kena darab 1000 lah. Okay, ataupun darab 10 kuasa 3 newton. Right, and then for the area, okay, it is in millimeter square, so you don't need to convert it. Okay, just simply kira sahaja pakai calculator Right, so you dapat 90 newton over mm square. And then we look at example number 2. A brick pier is 0.7 meter square, which means when it says 0.7 meter square, itu bukan maksud dia area dia adalah 0.7 meter square, bukan Maksud dia adalah area ni adalah kat sini 0.7 meter, kat sini 0.7 meter. So area dia A equal to 0.7 meter times 0.7 meter. That's what it means And 3 meter high and weight 19 kilonewton per meter cube. Okay, this one adalah unit weight because of untuk 1 meter cube of brick pier ni, 1 meter cube adalah 19 kilonewton. Tapi brick pier punya size bukan 1 meter cube. Okay, dia adalah 0.7 meter darab 0.7 meter darab 3 meter. Okay, jadi berat dia bukan 19 kilonewton It is supporting an axial load from the column of 490 kilonewton. Okay, let's just draw how does it actually look like. So you have this is the column, okay, and below the column at the very bottom you have the pier. So pier ni dia actually macam column, tapi dia lebih besar, and normally you akan pakai dia for bridge. The load is uniformly spread over the top of the pier, so the arrow shown merely represent the resultant of the load. Okay, so load ni 490 kilonewton. Calculate the stress in the brickwork immediately under the column. So stress in brickwork, the first one, we need to calculate the area of the pier, okay, which is 700 by 700, because the question asks you to find the stress in the brickwork immediately under the column. Maksudnya kena ikut size pier lah, sebab in the brickwork tu adalah pier tu, okay, bukannya column. Right, so dekat pier ni lah, immediately under the column. Okay, kat area sini lah, immediately under the column. Okay, tu yang diminta. Kita kira area. Okay, you know that 700 by 700. Why? Because of 0.7 meter. So you kena convert dia jadi millimeter. So what you need to do, you kena darab dengan 1000. Okay, so dia akan jadi millimeter sebab 1 meter equal to 100 centimeter. Okay, and 1 centimeter is equal to 10 millimeter. Therefore 0.7 darab 100 darab 10, dan dia darab 1000 lah, maksudnya become 700. Okay, so that is the area on the area part. And next we need to calculate saja dia punya stress, sebab dia kata stress in the brickwork immediately below the column. Okay, jadi kat dalam brick tu sendiri, kat dalam pier tu sendiri. Bila kat dalam, kita tak perlu kisah pasal berat pier tu untuk being include dalam our calculation. Therefore, we just take the value of the force, which is 490 kilonewton given in the question. We just convert it into Newton, darab 1000, and divide it with the area that we calculated up here, and you will get 1 Newton over millimeter square. As simple as that. For the next question that being asked is the stress at the bottom of the pier. When the question asks you to find the stress at the bottom of the pier, it means that you need to include the weight of the pier. As I said before, because total, stress daripada atas, daripada kolom adalah 490 kilonewton. And another thing that you kena campurkan, sebab ni adalah total stress, adalah berat pier tu sendiri. So the self weight of the pier. To get the self weight of the pier, what's given, it give you the unit weight of the brick of pier tu lah. Unit weight dia 1 meter cube adalah berat dia 19 kilonewton. Tapi pier awak berapa volume pier? So volume pier, the actual one will be 0.49 meter square. Because of, let's say pier you, the pier is like this. Column kat atas ni lah. You have the column on top. So size ni adalah, this one adalah 3 meter. Here it is 0.7 meter, and over here it is 0.7 meter. So when 0.7 meter times 0.7 meter times 3 meter, kenapa I tak convert into millimeter? Sebab kita punya unit weight adalah dalam meter cube. Kalau you nampak bawah ni meter cube. Jadi kita kena make sure that volume yang kita darabkan pada unit weight ni dalam meter juga. So that kita tak perlu, nanti kalau you tukar ni millimeter, you tukar dia millimeter, kat sini you kena tukar dia jadi millimeter juga, baru you boleh darab dia. Kalau tak boleh. That's why leave it in meter. Right, so after that we will get the actual value, the total force. And then you can just calculate the stress, which is force divided by area. Take the total stress and divide it with the area of the, so that is 1.057 Newton mm over mm square. Next, we look at example number 3. Determine the tensile stress induced in the rod due to an axial load of 60 kilonewton. Given the force is 60 kilonewton. We have the formula, which is sigma equal to F divided by A. So we have the F, but the area that we need is the area of the rod cross section, sebab dia perpendicular to the surface. So mana surface-nya, so the cross section of the rod, which means that kalau you nampak sini given it is 20 mm diameter. So obviously the rod is bulat lah cross section dia. So bila kita cut kat sini, kita dapat bulatan. So to calculate the area for circle or round, it is pi d square over 4, or you can also use pi r square. Masukkan saja pi, dia punya diameter 20 mm, power of 2 and divide by 4. Or you can use pi r square, so pi times 10 mm power of 2. Then you will get the same value, right? 10 mm radius, because 20 mm divide by 2. Then after that, we can simply calculate the stress, which is force divided by area. Masukkan the 60 kilonewton force, convert into Newton, darab 1000 and divide with the area in mm square, which is 314.159. Dan you dapatlah jawapan dia in 3 decimal places. Next, we go to example 5. So example 4 I'm going to skip, okay, sebab dia lebih kurang sama je. You can basically do on your own. Maybe you can buat sendiri and tunjuk dekat saya lah apa yang you buat ya. Determine the shearing stress induced in the rivet due to the shearing load of 40 kN. Here also dia bagi diameter of the rivet tu 20 mm, right? Therefore area dia adalah this one lah, okay, because dia tarik 40 kN, cross section rivet tu 20 mm. Okay, jadi masukkan saja, sama je cara dia, pi d square over 4 ataupun you can use pi r square, and masukkanlah value dia. You akan dapat 314.159. Dia sama je macam example number 3 sebab diameter dia sama 20 mm. Then just simply calculate the sigma ataupun stress. 40 times 10 power of 3 sebab you convert from kilonewton to newton and divide with the area, which is 314.159. Then you get 127.324. Then we look at example number, so I skip 6 and 7 sebab dia almost similar. So kita masuk example number 8. Calculate stress in the object. Here we have apa ya, triangle cross section. Dia macam chocolate Toblerone lah, dia panjang macam tu ataupun kemah. Okay, mungkin you boleh anggap ni like kemah 10. So this is the cross section, dia akan triangular. Okay, basically sebab mesti perpendicular to the object, the force. So you potong sini, you akan dapat rupa dia segitiga lah, which look like this, right? But okay, our problem here, we need to calculate the area of this cross section. Since kita tahu formula untuk calculate area triangle is setengah, okay, sebab setengah darab B and darab H, which is kalau you bahagi dua like this, okay, ini B and ini H, right? And since you ada dua, so that's why you ada dua triangle yang separuh like this. You ada dua benda ni, so that's why darab dua lah. So jangan confuse. So setengah darab P darab H itu adalah formula untuk triangle. Tapi kita tak ada value H. So to get this value H, so you know from theorem Pythagoras, okay, theorem Pythagoras, you ada value 10 cm kat sini, you ada value 5 cm kat sini. Tapi you tak ada this value because you need value of H. Ni H, ni B. To get that, okay, kita akan pakai theorem Pythagoras, which we know that kalau triangle macam ni, I call this A, I call this B, I call this C. So if I take A power of 2 plus B power of 2 equal to C power of 2. Right now, what I want is I want A. So therefore, A power of 2 equal to C power of 2 minus B power of 2. A ni actually adalah H lah, okay. Ini adalah A, adalah H So that's why, so A equal to C power of 2 minus B power of 2. And nak buang square dekat K tu, A tu, yang di other side you kena square root kan. Then you dapatlah macam ini. So A ni adalah H. Okay, so C kat sini, it is 10 cm ni. Tengok sini, boleh refer. C ni adalah 10 cm. Kuasa 2 minus dengan 5 cm. Sebab B tu adalah 5. Now you square root kan. You dapatlah value H. I dapat 8.66025438. Tapi kita round up kan. 3 decimal places, so jadi 8.660 ataupun 8.66 lah in centimeter. Biar je centimeter tak apa sebab kita tengah cari H je. Lepas tu baru kita boleh kira area dia. Okay, you can choose either you nak kira terus dalam milimeter ataupun you nak kira dalam sentimeter, tak ada masalah. Kat sini I kira dalam sentimeter dulu and then I convert into millimeter, sama je. So 2 ni sebab tadi I dah cakap dia ada 2 triangle ni. Kalau you tak pakai macam ni pun tak apa, you anggaplah B ni semua dari sini sampai sini. Okay, so tak adalah 2 tu. Okay, tapi sebab I ambil separuh saja, which is I anggap dia 5 cm that's why I darab 2. Okay, so setengah, sebab nak kira area, setengah darab B darab H. So B adalah 5 cm, I ambil separuh. So H adalah 8.66 cm yang kita dah dapat kat atas ni. Dan kita kira, kita simply dapat 43.3 cm square. Now, bila you dapat centimeter square, you kena tukar pada millimeter square. Nak tukar pada millimeter square, you know that 1 cm adalah sama dengan, okay, ingat ni 10 mm. Right. So kalau 1 cm square 10 ni pun you kena kuasa 2 kan. So kalau 10 kuasa 2 maksudnya darab 100. So 43.3 darab 100. You dapat 330 mm square. After that, kita boleh kira dia punya stress. So sigma equal to force divided by area. Just take the value of 10 kN ni as the force. Masukkan, divide with the area that you will get the value of stress. So don't get confused kenapa dalam drawing dia ada 2 arah macam ni. Sebab this one sebenarnya for the sake of equilibrium. Apa yang ditarik, yang being pull dia ada side akan pull, dia ada side also kanan pull, so kiri pun akan pull, equilibrium. That's the one the point. Tapi sebenarnya dia satu side saja yang ditarik lah. Tu je. Okay. Now we look at example number 9. Calculate stress in the shaft. So shaft kat sini dia ada 3. So kita kena kira one by one. Maksud saya kena bahagikan. Okay. Why? Sebab cross section dia dah berubah. Okay. Kalau you tengok kat sini, dia punya force semua perpendicular to the surface kan. So the surface adalah surface sebab dia bagi dalam diameter. Jadi surface dia adalah bulat lah. Okay. Like this. Okay. Like dia punya cross section. So bila cross section ni dah berubah size, jadi you kena kira untuk setiap yang you kena potong tengoklah kat mana-mana dekat bahagian shaft tu. Right. So first kita kira yang bahagian pertama, which is this one Okay, you nampak ada force 5 kN paling depan and the diameter is 5 cm. So just simply kira je dia punya area. Pakai area untuk bulatan sebab dia dah bagi diameter. Pi d square over 4 ataupun you can use pi r square over 4. Jangan lupa kalau you pakai pi r square, meaning pi times with the radius which is 225 lah. Bagi 2 kuasa 2. So itu adalah kalau you pakai radius And then kira je dia punya stress. Ambil the force yang acting or at the surface of the shaft tu. Okay, part yang you kira which is 5 kN. Tukar pada Newton, that's why saya darab 10 kuasa 3 and divide with the area that you calculated. Then you dapat 2.546. Next, we need to calculate the other part which is the one yang kita dah potong dekat sini. Okay, kita potong dekat sini. Okay, kita kira pula untuk that area. But kita kena ingat for that one ada 2 force kat depan ni. Effect this part sebab force dekat depan ni pun push juga this part of the shaft. Okay, jadi kira area dia pi d square over 4. Okay, masukkan je pi times 100 power of 2 divided by 4. Kalau you pakai radius, pi r square pi times 50 bagi 2 power of 2. You get the same value and calculate the stress. Okay, but notice here the force dah berubah. It is not 15 kilonewton sebab 5 kilonewton, although dia tolak dah yang bahagian depan, tapi dia akan effect juga another part of the shaft. Maksudnya dia punya bahagian kedua shaft tu pun ter-effect juga daripada force yang push it inside. Push dia ke dalam tu pun effect juga. Divide dengan area dan you get 2.546 juga. Then for the third part, sama je cara. Area dia adalah 15 cm kat sini dia punya diameter. Kena tukar 2 mm. That's why jadi 150. If let's say you pakai pi r square, then pi darab 75 lah power of 2. You dapat area, okay, dalam millimeter square, and you just kira dia punya stress. And here also 10 because of other force yang dari sini. Semua ni 3 So 15 tambah 5 jadi 20. Okay, ini 2 jadi 20. Tolak 10 sebab dia arah lawan. Okay, jadi you kena tolak lah 10 kilonewton jadinya. Dan force, maksudnya total itu adalah dia pushing to the left which is compressive force lah. Maksudnya total force tu adalah compressive force. Dan bahagian part ni dalam compression sebenarnya. Okay, dia dalam compressive stress. Sebab dia termasuk dia kena push inside. So it is compressive stress. Dapat 10, bagi dengan area dia, then you get 0.566. Okay, done. Next, we look at example number 10. Calculate the stress at the bottom of the pyramid if the density of material is 2,700 kg per meter cube. Okay. For this one, if you notice, dia bagi ni. Ini adalah density. And dia bagi dimension of the pyramid, tapi tak ada force. So, tapi dia cakap calculate stress at the bottom of the pyramid. Meaning you kena cari stress dekat bahagian bawah pyramid ni lah. Okay. First, kita kena kira volume pyramid ni. Sebab if you notice, dia bagi density per meter cube. Maksudnya, density pyramid ni adalah 1 meter cube bersamaan dengan 2,700 kilogram. Dia punya mass. Okay, ni dalam mass, bukan Newton. Kalau Newton tu berat. Kalau kilogram tu mass ataupun G same. Kita tahu 1 meter cube 2,700 kilogram. Tapi berapa meter cube actually this pyramid. Okay, that's what we need to find. So 1/3 formula untuk kira volume pyramid adalah 1/3 darab B darab D darab H. So B is 50 meter, D is 50 meter, ni B and H adalah 30 meter. Therefore, you dapat volume dia 25,000 cube. Untuk dapatkan dia punya force ataupun weight dia, you just simply, sebab you tahu ini adalah dalam mass, okay, kilogram. Sebab dia bagi you density, jadi you kena convert dia pada Newton lah. Sebab dia bagi dalam kilogram. So you kena convert dia jadi berat. Daripada mass, you kena convert dia jadi berat. So kalau you nak biasa you kira, you tahu force sama dengan mass darab dengan gravity acceleration. Itu bezanya force atau weight sama je. Berat ataupun force adalah sama dengan mass darab dengan gravity acceleration. Kalau you tengok kat sini 2,700 ni, okay, bila you pangkah this one dengan this one, you akan dapat dalam kilogram. Betul? Jadi bila you dapat kilogram, sebab you tahu 1 meter cube 2700 kilogram. Okay, so tapi sekarang volume dia bukan 1 meter cube. Volume dia 25,000 meter cube. So 25,000 kena darabkan 2700 kilogram. Jadi you dapatlah berapa dia punya mass, which is kilogram lah. Sebab ni semua dalam kilogram dah. Okay, dia punya mass. Dan ikut formula ni, mass darab dengan gravity acceleration, baru you dapat weight. That's why you darab 9.81, which is the gravity acceleration. Okay, so you dapat value dia sebenarnya 662.175 darab 10 kuasa 6 kilogram unit dia sebenarnya, kilogram meter per second kuasa 2, which is sebenarnya 1 kilogram meter per second kuasa 2 ni adalah sama dengan Newton. That's why kat sini dia tulis Newton. Benda ni sama. We can calculate the area of the bottom, at the bottom of the triangle, sebab dia minta stress at the bottom kan. Jadi bottom of that, bukan triangle lah, bottom of the pyramid. Okay, so area dia adalah 50,000. 50,000 ni macam mana? This come from 50 meter. So 50 meter you convert into millimeter, you darab dengan 1000. Okay, sebab 1 meter 100 cm. 1 cm 10 millimeter. So daripada 1 meter nak pergi ke millimeter, kena darab 100 darab 10. Right? Jadi darab 1000 lah. And okay, dia both side Jadi you dapatlah area dia. Then you just simply kira dia punya stress, which is 662.175. Sorry. 662.175 times 10 power of 6 divide with 25 times 10 power of 8. And you dapat 0.265. So 3 decimal places. Okay, we are done here. Then we are finished with the stress. We go next to the strain. Okay, for strain, when loads of any type are applied to a body, the body will always undergo dimension changes. This is called deformation. Maksudnya perubahan bentuk. Okay, jadi deform. Tensile and compressive stresses cause changes in length. Torsional shearing stresses cause twisting, so berpusing And bearing stresses cause indentation in the bearing surface. For example, normally kalau bearing stress ni, it happens to steel connection. Contohnya macam screw, macam rivet, okay, yang dia ada bearing, maksudnya ada sentuhan, ada surface dia in touch with each other. Jadi dia prone untuk kena bearing stress. Okay, sebab dia bergesil, dia bertemu. Jadi kalau katakan ada force yang tarik dia, dia akan indent, dia akan effect. For example, if you have plate macam ni, awak ada dua plate, you sambungkan dua plate ni plate. Okay, jadi you sambungkan dengan screw. So ini screw, lubang ni So kalau katakan ada force yang tarik kat sini, so awak punya screw ni akan indent, akan pecah. Okay, jadi itu adalah bearing stress sebab surface bergesil. The measure of this change in shape is called strain. Jadi perubahan shape tu kita panggil dia strain. For example, we have here case tu, dia bagilah formula strain is equal to increase in length ataupun decrease in length. Maksudnya change in length lah. Okay, Adam ni, okay, change in length divide with original length. Okay, so change in length we can panggil dia delta, ataupun you can also pakai segitiga L tu. Segitiga tu maksudnya change change in length divide with length, which is the original length. Change in length if you look at yang kat bawah ni, this one, okay. So this is compressive force yang menyebabkan this bar ni, okay, for example this is a bar, akan memendek lah. This is not what we call elongation, sorry typo, this is shortening. Okay, memendek, dia shorten sebab dia compressive force, right? So perubahan ni kita panggil dia change in length ataupun decrease in length lah. Divide with the original length kalau you nak kira strain. And for this one, okay, dia akan elongate because of we have tensile force. So the elongation, okay, kalau kita kira, so delta divide by original length, so you dapatlah dia punya strain. So strain delta ni can be elongation ataupun shortening. Berapa banyak perubahan itu divide dengan original length dia. So unit of strain, by definition, strain is the ratio of the change in a dimension to the original dimension value. For example, length divided by the original length, area divided by the area, volume divided by the volume. Okay, so maksudnya area pun divided dengan area, volume pun divided dengan volume. Jadi tak adalah dimension, it is dimension. Sebab kalau you tengok delta ataupun change in length ni, kalau you divide with the length, also dia akan, for example this one dalam millimeter, ini pun dalam millimeter, so pangkah-pangkah hilanglah dia punya unit, so it is unitless. Kita tamat sudah saya punya recorded video this time. Right, so I'll see you again next week. Kita akan proceed lagi chapter 1. I bagi recorded video lagi sebab chapter 1 semua saya bagi recorded je. Chapter 2 baru saya start kita buat Google Meet. Right, so thank you so much everyone. Have a nice day. Assalamualaikum.